Hello, and thank you for coming along to my Inventor tutorial, which I've cheesily and somewhat regrettably called Get Loft and Get Creative. The name of the tutorial is based upon the primary tool which I'll be using in this guide, which is the Loft command, which you'll find in the Part Environments ribbon bar. Now, the Loft command's been in Inventor for quite some time. I want to say it came out in around about release 10. That's not 2010, that's release 10, which is about 2008, I want to say, ish. So it's been in for quite some time. However, I found on my travels that not a lot of people have used it. They've not dived into it. When they go about, self-teaching themselves, they stumble across it, maybe open it up and go, "What the bloody hell is this? Christ, forget that." So yeah, I found not a lot of people use it. Now, if you have used it, then good for you. So it begs the question what you're watching this for, but you might learn something maybe. But yeah, it's quite a good command. It allows you to get creative with various different shapes and forms. What it does is it takes two sketch profiles and it will blend a solid between two sketch profiles. Now, those sketch profiles can be of any shape, any size, and any place within reason, and it will blend a solid between those two shapes. Now, you can sort of let your imagination run wild with this a bit. You can create all sorts of funny forms and create kind of shapes. It's used for product design mostly, or you could use it for sheet metal for squared arounds as the image depicts, but there is a sheet metal function for that, which I'll not get into. But yeah, so as I get through this tutorial, I'll be showing you other different areas of Inventor which I'll be using to get to the end point, which is to create a lofted shape, and hopefully you may pick up something as I go through, and I'll be explaining what I'm doing as I go through. So I'm starting with an empty part file. There's nothing going on in here whatsoever, and I'm going to start by creating a 2D sketch in a completely empty part file. I'm going to sketch on the XY plane. Now, I'm using Inventor 2015. If you are using an earlier release of Inventor, you may not see these work planes, these sort of construction planes appear in the center of the screen. If you don't worry about it too much. If you want to sketch on the XY plane, as I am doing here, you can expand the origin folder down here and then pick it in there. Everything that I do in here, you should be able to do in an earlier release of Inventor. So you don't have to have release 2015. So sketch on the XY plane, and here we go. Now, to create the solid that I'm going to end up creating, I'm not going to be sort of taking the shortcut and playing the easy card here. I'm not going to be creating primitive circles and rectangles and squares. I want to get a bit more funky with things. And I'm going to be using the Spline tool, which allows you to create sort of non-standard shapes to create sort of weird and funky products with. So there's a number of different splines. Now, the one I'll be using is the interpolation spline, which basically is a fancy word for saying you draw some points and it bisects a spline between those points. Now, the best advice I can give you for creating splines is to not just click random points like this and hopefully, and hope for the best that you get a nice symmetrical, lovely shape to work with, because you'll end up spending the rest of your life dragging points around and, well, that doesn't look right, let's move that here. Let's move that down here. No, it's still not quite right. Well, where's the bottom point there? And then you move this along here, and it starts to do. Yeah, it's not the best approach to sort of randomly do it on the fly. The best advice I can give you is to plot out where you want your major spline points to be first before you create your spline. And you do that using the point tool here in the sketch ribbon bar. So select point, and then pick some approximate points where you want your spline to intersect. Now, I want a kind of egg-shaped kind of spline going on. So I'm going to create 4 spline points. And they're all going to be based around the center point. What I want is my profile to be symmetrical around the center point, because the center point is going to become quite important later on. I'm going to use this for a path, which I will explain a bit more about later on. So I've got these points here. These are kind of just floating around in space. They're not constrained. If you've been working with sketches quite a lot, you'll know what not constrained means. It just means that they've got no dimensions. They're not fixed in space. They're not referencing anything else in the part environment. They're just sort of free to float about. So I need those to be constrained. I need to tell Inventor where I want them to be. So I can use the standard 2D constraint panel, which is up here, and I can use the dimension tool. So I'm going to get started by just making this a bit more structured. I want to make things a bit in line and a bit more rigid. So we can create the horizontal constraint, pick that, and then select these 2 points here, which will line those 2 points up horizontally. So when I grab and move these, they sort of move up and down with each other because they're horizontally fixed together. I want to do the same but vertically for the top and the bottom points. Just to confirm what that's done. That's made sure that those 2 points are now vertically in line with each other. I'm going to create another vertical constraint and make this point here vertically constrained with the center point of the part, and that will align both points up so they're sat on that central axis running through the part file. Super! Right, well, what next? Okay, well, the next thing I want to do is make sure that these points are symmetrical around the center line. How do I do that? Well, you could just create a dimension, say maybe make a dimension from there to there, say make that 10, and then put another dimension. I'm pointing at the screen like you can see my hand, but you kind of, but maybe put a dimension there of 10 and then make another dimension from here to there is 10. But that's not really best practice. The best way to go about doing that is to give yourself some center lines to work with. So you can say project geometry, and then you can use these axes. The reason for this being such a good idea is these axes will never ever change. They'll never move. They'll never vary. They're a fixed constant throughout the part file. So grab those axes. Once you've projected them, and then select them and then convert them into construction lines. Now that doesn't really serve any purpose other than it just makes them a bit more sort of out of focus. They're not so prominent on your screen anymore. So now that you've got this center line here, what we can then do is create a symmetrical constraint, which is this one here, and then pick these 2 points, pick that point, then that point, and then this axis, and then that will make these 2 points symmetrical around that axis. Way great, eh? Right, you can do the same thing, symmetrical constraint between this point here, and then this center line here, and then that will do the exact same thing. Make these 2 points symmetrical around that axis. So now we've got that done. The next thing we can do, if you want to, is plate some dimensions. Now I'd be quite alright, now that everything's symmetrical, to create a spline between these points, but if you are designing a product, you might want to put some dimensions on at this point so you know what kind of size you're working with. So we can maybe create a dimension from here to here and make this, say 25. You might want to put a dimension from here to here and make that, I don't know, 30. Whatever, it doesn't matter. I'm just sort of making this up as I go along, if I'm honest. And then make that one 10. Now all those sketch points have gone blue. When a sketch line goes blue, it does, I don't want to get into too much depth, but depending on the color scheme you're working with, they can go a different color. But when they do change color and go to a darker color, generally means that they're constrained. And when they're constrained, it means they can't move. You can drag them in, they don't move anywhere. Right, now that I've got those points and I'm happy with those points, I'm going to select the drop down list here and I'm going to select interpolation spline. Now, the bizarre thing about this, and again I don't want to get into too much detail, but when you select spline and you start splining through the points, the start point does kind of make a difference. Now if you look what I've done there, I've started at this point and I've gone clockwise and I've got this sort of bizarre off egg shape here. No good. No good at all. So what I want to do is go back to the spline command, start at the bottom point and then kind of go anti-clockwise, and then even though I'm going through the exact same points, look at that, I've got a lovely symmetrical egg-shaped spline, which I'm happy with. And I say I don't want to get into the detail of why it's different, but you tend to start in a symmetrical center point and then go around. If it doesn't work out quite right, start at a different point and try again. If you're quite confident that your points are all in the right place, everything's symmetrical, just keep trying. Start at the right point and just keep trying. Okay, so that's my first profile done. That's the first profile that I'm going to use with the Loft command. I'm going to finish the sketch. Now the next thing I want to do is create a path. Now the path is going to be, it's going to kind of be like a center line that the loft's going to go through. You can loft between 2 profiles. I could just draw another egg-shaped profile here and just loft in a straight line between 2 points. But you can also loft and tell it to follow a curvy path if you want. What do I mean by that? Right, well I'm going to create a sketch. And I'm going to sketch on this plane here, which is, because I've made everything symmetrical around that center point, this plane here runs smack bang through the center of the sketch. It is effectively a center line. If I just turn around, you can see there I'm sketching on this plane here, which is central through that sketch. Okay, I want to create a center line. It totally depends on what you're doing. Obviously I can't explain every eventuality of sketch line that you can create. So what I'm going to do is create another spline. I'm going to start at this point here, and I'm going to come maybe here and then down to, let's say, there. That'll do. That's going to be the center line for my loft profile. However, if you look at where the spline comes out of the profile, can you see it sort of bends up before it goes down? That's not good. I want it to come out perfectly normal from the sketch plane. I want it to be a smooth transition out and then down. Because if I do loft a profile along this line, it's going to kind of go up and then it's going to go down. It's not going to terminate against this sketch profile kind of perpendicular or normal to that sketch plane. So we need to sort that out. Now there's a number of ways of doing that. Again, like everything in CAD, there's a number of different ways of doing this, but I find the best way to do it is to look at the handle of the spline. What the bloody hell is the handle of the spline? Well, I'll tell you what it is. If you select the end point of your spline, you get this little line appear here. Now that's the spline handle. If you try and select it, it's going to troll you. It's going to just vanish. You'll be like, what the hell? So what you do is you select the dot, right click, and then you activate that handle. Now these little green dots here, if you pull the handle, you'll see you're modifying how the spline behaves at that point. Now I don't want to get too technical with this, I just want to keep it simple. So effectively what I'm going to do is make that spline handle horizontal. So you select the horizontal constraint, select that spline handle, and hey, look at that, it's not actually horizontal because the sketch has been flipped. It's actually vertical, which is a bit mind-boggling, but never mind. Make that spline handle vertical. And now you can see, if we just exit the handle, it now comes out perfectly normal from the sketch plane because the handle is flatlined through the sketch profile. Lovely. Lovely jubbly. Right, I'm quite happy with that profile. I'm going to finish that sketch, and the next thing I need to do is to create my second profile, the one that's going to start the loft. This is the termination profile. I want to create a new profile around about here. How do I do that? I've got nothing to sketch on. Well, I need to create a work plane. How do I create a work plane which is going to be exactly where I need it to be on the end of this line, kind of making sure it's going to blend smoothly into this path? Right, well, the way you do this is you select the work plane command, pick the end point of this line, which should appear, and there you are, and then pick the line itself, and it will give you a work plane which is perfectly normal to that spline. To test that this is actually adaptive and it's going to move with the spline, you can pick up the end of that line, move this to say here. It's not updated. Right, we'll click the update button here and it will move. There you go. So your work plane's always going to be perfectly normal to the end point of that line. Happy days. Next thing to do is to create your sketch on this work plane. Inventor will move the camera so it's looking straight down on the work plane. Now we're not going to worry too much about what's going on down here, we're going to be worried about what's going on up here. Okay, next thing to do is just to create another shape. Now this could be anything you want. It could be just a square, it could be just a circle, it could be anything you want. But I'm going to create another spline. So I'm going to create a point, say here, point there, point up here, another one there, another one about there, another one about there. I'll do. Okay, and I've got to go through the rigmarole again of making sure all the points line up. The reason I'm doing that is because if it's an off-shaped spline, if it's not symmetrical, you're going to start your loft in a bad way. The profile that you're starting the blend from is going to be off-center, and you're just going to get this horrible, ugly-looking solid sort of blending into another profile. It's just going to look awful. So let's start by doing the horizontal constraints between here, and then here, and then here. Did that do that one? Yes, it did. Okay, alright, and then we'll do a vertical constraint between here and here, and then this one, and then, nothing to pick. There's nothing to pick there, so what we're going to do is project the geometry of the center point, and that'll give us a point which will allow us to vertically constrain that point to that point. Good times. Right, for the center lines, to make everything symmetrical, I'm kind of now off the part axis. I'm not kind of like away from the center point of the part, so I can't really project the axes now. So an easy way to make yourself some center lines is to just start the line command, make it a construction line, and then draw yourself a center line going across here, and then draw yourself a center line going up there. And then we can use this symmetrical constraint to make that one symmetrical to that, and then same again, just repeating what we did before, that one and that one, symmetrical. That should have done that. Yep, that's working like a treat. And then those, nope, I haven't done those ones yet, so we'll make that one and that one symmetrical around the center line. Great days. Okay, right, so for the size of this profile, now I want this to be a bit larger than that profile. I want it to be sort of a larger shape blending down into a smaller shape. So just to get the size approximately right in the first instance, I can sort of move these points over here and move those points over there. And if I wanted to, I could put some dimensions on them. I'm bothered about those, not really, but I'll make the center ones symmetrical. So we'll say 4, and then there. Yeah, well, that's symmetrical, so it's going to be okay. Right, the next thing I'm going to do is my spline. So I'm going to start by doing the exact same thing as I did before. The interpolation spline, I'm going to start at the bottom and then spline out to here, through there, to that point, and then back to the start. And it's made a construction line, so we'll just select that and then take that. Okay, so there's our profile. It's a bit funky looking. You can grab the handles if you want to and move it around and pull it around to make it a bit more specific. If you want it to look a little bit different, like I say, your dimensions, if you are designing a product, you would put dimensions on there, but I'm not overly fussed for the purposes of this tutorial. I'm quite happy with that. So we'll finish the sketch. Now, just to make things a bit more visually appealing, I want to switch off that work plane because I don't like having work planes in my face once I've finished with them. Turn that off. Right, that's it, done. So the next thing we're going to do is to create the loft. What I'm trying to achieve here is to blend this profile into this profile, but I'm going to run it along this path here. So we'll create a loft, and the curves are going to be the sections. Click to add. So we're going to go from here to here. Now, as you can see, I haven't selected that little line going through the middle of there, so it's going to do an as the crow flies blend from one shape to the other, which is fine. That's absolutely fine, but I want it to follow the center line. I want it to blend and curve along that center line. So I then select this one here, which I've said probably enough already, which is the center line, and then you select the sketch, which is going to be this one here. Oh, look at that. Not great. So it's going to blend those two profiles together along that center line, and then you go, okay. And then look at that. Look at what you can do. Looks absolutely fantastic. Well, it looks a bit drab actually because it's just in grey, but then you can sort of go into your colours and you can go to the sort of the salesman's dream, which is the chrome polish. Wow, look how shiny that is. That's looking good. Now, if you are in product design, one of the good and again underused aspects of Inventor is the zebra analysis utility, which allows you to inspect the surface quality of your models. So visually, just looking at this, yeah, it looks pretty smooth, it looks all good, it looks funky and hunky-dory. If you select this zebra button here, which is on the inspect tool, you can mess about with the density and whatnot, but select OK, and it turns your model into this sort of pinstripe zebra contour. And that just lets you inspect surface quality. So if there are any sort of weird off-symmetrical maybe surface breaks in the model, maybe the loft didn't quite go perfectly symmetrical, you'd see that immediately in the zebra analysis. But as you can see, it is absolutely smack bang perfectly symmetrical. Okay, so just taking that one step further, I've sort of got this Blue Peter job going on here in the background. So this profile here and this profile here, that's pretty much the same as what I've just created. But then I've created an additional couple of profiles here, finishing with just a single point. Now they've been created in the exact same way as my other, is the last example was just a profile on an angle, a center line, and another profile. And these ones here are just sort of offset profiles from that one there, in the same angle. So with the loft command, not only can you go from here to here, following sort of a guide rail if you like, which gives you this, you can then create additional lofts. You don't even need a sketch for it actually, you can pick a solid face and then sketch from loft from here to here to here, and you can loft through multiple points, and it will, you can come up with some really quite creative shapes. It all depends on the inputs that you give Inventor to work with. Right, a couple of other things just to finish this off. This loft coming out of here, you can see there is, you don't even need the zebra analysis to look at it. You can see there's a clear sort of deformation there in the surface. It's not a smooth transition from one profile to the other. But just for clarity, I'll switch this on. You can see there, that's what the zebra is showing up. Like there's a clear break in the surface. So, how do we get a shot of that? Right, well, I'm going to go back into the loft, the last loft that I created, which is loft 9 in the browser. Edit that feature, and then go to the conditions. Now, the conditions, again, I don't want to go into too much detail, so I'll stop short of being a training course, but this this edge here, this is the transition between the first profile and the rest of the loft. So, you've got a number of different conditions you can work with. The free condition just means the profile's coming straight directly out. The loft's coming straight directly out of the sketch profile. If we make this a smooth G2 condition, it will blend, it will try its hardest to blend the profile normal to the sketch that it's coming out from. There's still a tiny bit of a break there, but it's a hell of a lot smoother than it was. If you go back to Zebra, you can see it's made a big difference. It's not quite perfect. There's probably a little bit more work to do there, but it's better than it was before. I'm happy with that. All right, and the final point I've blended the final point of the loft into a sketch point. Now you can see here it's sort of terminating into an absolute razor sharp point, which good luck trying to manufacture that and getting it past any safety audits. But go back into the loft, edit the feature, go back to the transitions, and this point sketch here, this is the final point where the loft's terminating at. If I select this drop down arrow here, it knows that it's blending into a sketch point, so it lets you toggle how the loft ends on the point. Now you can change it to say a tangent loft into a tangent point, so it'll sort of make a smooth spherical termination point, and you can increase the weight of that tangent point like so. You can sort of just trial and error, just bump it up a bit, add a bit extra weight there, and we've got something much more manageable to manufacture. And as you can see, it's a rather cheap, so 10p disposable razor. Okay, so that's the loft command. I hope you found that useful. Like I said, not a lot of people have used that before, but as you've seen the processes I've gone through, you can use any shapes you want. You can create any sketch shapes, any sketch profiles, any center lines you want, any distance and any size, and you can create literally anything you want using the loft command. The world's your oyster. Depends on what your imagination can do. And also, as I've shown, is the spline command. A couple of tips and tricks on how best to get the spline command to work for you, and the zebra analysis tool, and a couple of the transition effects which you can use within the loft command. Thank you very much for checking this out. If you did find it useful, apologies, it's quite a long one, but these things do take time. You cannot figure out Inventor in 2 minutes. It's quite involved. But thanks for your patience. Stick it out until the end. If you did like the video, press like on the video. That would be great. It helps me out. I'm just getting started, so it'll help me create some more videos, get them shared around a bit, and put some comments in. If you've got any questions, I'll be happy to answer them. Thank you very much for your time, and good luck with playing around with it. Thank you.